Hi everyone, thank you for inviting me today. I lead a team in Nokia of engineers and researchers dealing with 5G for enterprise and digital industries. Our day-to-day job is to try to figure out what it takes to make 5G successful and the future of 6G successful for enterprise and verticals. This is part of our mission. I'm taking part of 5G ACIA together with Afif. He made a presentation this morning. A lot of people have been looking at XR as a new revenue stream, and this was mentioned by Kamal earlier today. And we have been looking at this for more than a couple of years, and we had one basic question. Are networks ready to support XR applications at scale? So this is the simple question that we try to answer. And we came to the conclusion that it's yes and no at the same time. It's yes because, and by the way, we have been looking at this not only from 5G perspective, but also from fiber to the home and Wi-Fi and other kind of networks. It's yes because we can run today XR application on top of 5G, but the problem is when we start to deploy at scale XR services, we will run into congestion problems. There are other issues that we need to solve, like uplink capacity. There will be a presentation about this from Camille later on. And we need also, because energy efficiency is such an important subject, we need to make sure that we optimize the network, taking into account the XR traffic characteristics. Maybe very, very quick reminder about XR. This is the known devices, but it may evolve in the future because there are other form factors, and hopefully other form factors will appear, because right now the form factors are not very, very good for super user experience. And also the price points needs to evolve to price points that will allow mass scale deployment. Very quickly, virtual reality is when we have a virtual scene which is projected into your eyes. It could be about cloud gaming experience. It could be about a visit to a museum here in Istanbul. Augmented reality is when you have the real scene in front of you and we overlay on top of it digital information. It could be about guidelines, pricing, or depending on the application. And mixed reality is when you combine both. And as I said, you could have other devices like the ones that we use for the globes, that we use for getting more information. So I think I spoke about this, but when we did this journey of looking at XR, we came to an important conclusion, is that it's going to be very, very difficult for this network industry to figure out all the components that we need to take into account in order to evolve the network. So for instance, if we are exposing APIs towards applications or developers in order to provide the information about the quality of service that's needed, I think we need to work with the application and the platform vendors. And we came to the conclusion that XR and the evolution towards metaverse, it's wide in scope. And this is why the industry needs to work together to solve the interoperability issue at scale, not limited to networks, because otherwise we end up in huge integration problems, and that makes all the business cases collapse. So we joined as Nokia an association called the Metaverse Standards Forum, where we have those kind of expertise. If you look at the XR traffic characteristics, we came to the conclusion that there is no single size fits all. Some of them will require high throughput, some of them will require low latency. And within a particular XR sessions, you can have a mixture of video traffic, 3D models, voice, and other conversational services like UEPOS, which is the information that we send upstream to the application to provide the location and the position of the head, so that the rendering of this particular scene is in accordance to the user needs. I will, how do I, no. I'm trying, okay. And those requirements, of course, will have, can take into account if you need higher definition, then you increase the throughput. If you have improvements in codecs, then you lower the throughput. If you add haptics and sensors, then you need more interactivity, so lower latency. The 3GPP has been busy for release 16 and 17, dealing with something we call industrial IoT. And industrial IoT has been around things like very, very low latency, high reliability, but there was no demand for high throughputs. XR is different, on the other hand. XR is about somehow low latency, but not as low as in the industrial IoT. Much higher data rates, bursty traffic, and sometimes periodic traffic. And within an XR session, it's important to figure out that there could be multiple flows. And it's not feasible if you want to optimize the network that you handle all the flows in the same manner. So we need to make sure that we optimize the network, taking into account those different flows within the session. And then what we understand is that edge, any form of edge, I think we have metro edge and far edge, will play an important role because you want to make sure that you can support eventually any kind of devices, even the ones that do not have the CPU power to process complex 3D models. So if you look at the protocol stack, you have applications, XR runtime, scene managers, and media access function. In initial deployments, I'm not able to get this to run, but in initial deployments, those sit at the device, and we have a server side, either on the edge cloud or on the cloud. But further down the road, for us to be able to support any kind of devices, we are thinking about some of those functions to be done at the edge or at the cloud, which means that the processing of 3D formats can be done at the edge and only a video throughput is sent to the device for the rendering. But we can imagine also other forms like split rendering. For instance, simple 3D formats are processed locally, and more complex 3D formats are processed at the edge clouds. And here we start thinking about trade-offs like throughput on the network and energy efficiency and so on. So it's important that we take into account this evolution path, which is edge. This is about few use cases, and I'm trying to do this. I cannot get it to work. It's a bit different use cases. Maybe the one at the bottom is about cloud gaming, where we speak about 6 degrees of freedom. The one at the right is where you have a head-mounted display equipped to the camera, and you send uplink the video traffic to a server, and the server will locate you and will add additional information that gets displayed on your device for augmented reality. Which means when it comes to traffic, we are roughly speaking about uplink and downlink video traffic. Eventually up to 30 or 45 megabits per second, 10 megabits per second for uplink. We have audio streams, 30 milliseconds packet delay budget. We have motion control, for instance, this UE pose, and it's very time sensitive. Typically, we are talking about 10 milliseconds because you want to make sure that you adapt the scene in accordance with the head position of the user. I see that the time is running very fast. Again, we did simulations based on different assumptions, and this is validated by 3GPP. And again, the conclusion that release 15 and 16 of the GPP can support but we will be limited in terms of number of sessions. And I think very important aspect, we need to cope with power consumption, and this is another area of developments. So 3GPP has been busy in the context of release 18 to work on some of those extensions. I want to make zoom on two of them today. This slide makes a summary of the extensions in the context of 3GPP. Very quickly, uplink capacity, I see a speaker here who will be talking about this after this talk. It's about additional coverage and additional throughput. Another area is about how do you make sure that your scheduling and handling of the traffic is taking into account the different traffic types and flows of an XR sessions, which is matching scheduling with XR services. Application network interaction. So this is about exposing the network to the application, and that's part of monetization strategies as well. For instance, you want to make sure that your application provides the network with enough information to ensure the traffic gets through and to help the user experience. Power saving and media services, I will skip some of them in the interest of time. Getting slightly more technical for this slide, and I apologize if it's a little technical, but I want to zoom on one feature which we call PDU set. And this, the whole idea of this PDU set is if the application, which is at the right-hand side here, oh, I can see it, but it's in green, can tell the core network that I have this kind of XR session. So the protocol description, the PDU set, etc. And if the core network can mark the traffic in a way that allows the radio access network to handle quality of service. And here we are specifically talking about loss and scheduling for delay budget. I provide enough information for the radio access network to optimize traffic handling. For instance, if you are familiar with video traffic, there are three kind of frames: I frames, B frame, and P frames. If you drop a P frame or an I frame, then you completely drop a group of pictures. But if you drop some of the B frame, there are no impacts on the other pictures. And this is the actual information that you can convey in those PDU sets. Which means in one PDU set, I can say this is a high priority PDU set, number of packets with I frames, never drop. This is a B frame PDU set, so if you run into congestion, you can drop. And I can say this is about conversational or low latency traffic, so please handle it with a low packet delay budget. Another features that we have been working on initially at the IETF, which is called low latency, low loss, and smart throughput. L4S, Jacob spoke about this initially. So what is it about? So some of the applications can reduce the bit rate if I provide information from the network to the application about congestion level. For instance, if you have a codec at the application side, and if the network can tell you, oh, there is a congestion right now, then the codec can reduce the bit rate so that you can cope with congestion in the network. The way we do it is there is, in the IP header, there are specific bits called early congestion notification. So when we send the IP flows, we can send information about those early congestion notification towards the application, and we can reduce it. So this mechanism is reactive. But if you have multiple XR applications which react to congestion, you can increase the number of sessions that you can support on the network. And XR is, of course, part of a bigger story on evolving to the metaverse. Metaverse has this concept of digital twin, which is a representation of the physical world and 3D models, etc. I don't think we have time right now, but there is an evolution plan where we can support some of those features in the future with the evolution of 3GPP networks. Last slide, I spoke about interoperability, but we see interoperability as a big context. I don't think we can solve the interoperability at the network only. We cannot do it as a networking industry by ourselves. We've been taking part of this Metaverse Standards Forum. It's the place where you see the device vendor, the researchers, the XR platform vendors, the digital twin vendors sitting together. And we've been trying to figure out the big picture. We don't do any standards, but we want to make sure that we provide requirements to standards organizations, including for the network industry, to ensure that we support those requirements and that we are market driven. Thank you very much for your time. Sorry, I'm 1 minute late. But if you have questions, I'm happy to handle them.
Thank you, Mr. Elloumi. We're still running a bit late, but probably can take one quick question.
Hi, the question is about application-aware QS. You presented about the new feature.
Can we get the slides up, please? Yes, please go ahead.
What kind of relationship is there network slicing and application-aware QS? I create some picture. How is the convergence? Is a subset of network slicing?
Let me be very honest, I didn't think about this question before. Because we did this exercise from the context of regular internet access, where the application can provide via, there is a box called the network exposure function, where you can request quality of service, etc. And this particular proposal supports the fact that you have an additional API to inform the network about your flows needs. I suspect that in the context of a slice, you can have predetermined flow characteristics, and that may remove the need that you have this additional interaction with the application at the right-hand side.
Good.